Hope this works okay. You hear me just fine? Cool. I'm really excited to be here. This is awesome to be here at Go West. This is my first time giving a conference talk, so I'm a little nervous. We actually have live code, so we'll pray everything will work. That's what we're hoping for, right? So she did a great introduction. I'm a software engineer at Vasion, and I've been in the Go community for about 4 years, writing Go for about 4 years, and I've come to love it. So today we're going to talk about database SQL. We'll look beyond it and the pattern that drives it, that I've named here the driver pattern. So let's dive right into the agenda. I want to look at some database, what I consider magic. It's not really magic, it's just clever code, but we'll take a look at it. We'll look at dependency injection, how the pattern used in database SQL is different than normal dependency injection. We'll look at what this pattern really is, the portable type and driver pattern, and specifically the driver, and then we'll talk about event buses at the end and how it all ties in. So to start off, I wanted to look at some database magic. I have some live code here. I'm going to move this here because that's what I'm used to. If we look inside this folder, I have a couple different sections for the talk today. One about databases, two about caches, and the third one about event bus. So we'll look into the first one to start off, and we'll go right into main.go inside here. So this is a simple script that I wrote before coming on to go and get movies from a database, specifically movies where their rating is greater than 4. So we have this simple query to go and get all the movies where the rating is greater than 4. So 5 out of 5, only good movies. That's all we watch, right? So it goes through, it goes and gets all the movies and prints them. Currently it's set up to use a Postgres database. And I have a little Docker compose that will spin it up for us while we're here. So, and that will spin up Postgres for me, and we can run this, and we should get all movies that are greater than 4. So all movies where the revenue or the rating is 5. So that's simple. So let's look at how that really works. In order to talk to a SQL database, you import database SQL. You then have to do a blank import for the driver, PQ being the Postgres driver in this case. Then you open the database and you pass in the database driver you want to use as a string. And then you get a DB out of it and you can query off of that. That's what we ran our query off of. And so it's kind of that simple. That's all we had to do to show it here. We have that SQL open and we have that query. And it's awesome. This driver is just this Postgres and it's right there. But if we wanted to switch what database we're using, all we have to do is change that blank import and change the string for the driver we're picking, and then it uses that new driver, right? So if I go here and I've already prepared a SQLite database here, I can save that, we can go run, and I've seeded them with the same data, so we should get it. I can take down the Postgres server and we can run it again just to show we're hitting the SQLite version as database instead of the Postgres one. So there's kind of some magic in there. We were able to just change the string and we were able to still query the database, all the same stuff come out, which is kind of cool. But that's kind of different than dependency injection. And to really explain that, I want to do a quick recap on dependency injection. Many of you might actually be familiar with it, but we could do a quick recap. In this example, I'm using a cache. If you're familiar with Go dependency injection, you know you create an interface and then you create structs that implement the methods on that interface, and then it thus implements the interface. So I have this cache that has a get and a put. Really simple. We could add time to live and stuff, but for this example, it's just a simple example. And then if we wanted to create a struct that implements it, in this example, I'm using an in-memory cache, you would just implement those methods, the get and the put, right on there, and then you have one there. So I have that example as well. If we go into the to folder, we can look at the cache. We have the 2 methods I showed on the slide. And I've also implemented here the in-memory cache, like I showed. We have the get and the put. And same for the Redis. I've also implemented Redis here, and it has the get and the put as well. So if we look at our main.go, this one, we create a cache. Depending on the switch statement, we'll create a Redis cache or an in-memory cache. We put a simple key value pair on it, data to go rocks, and then we get the data out of it, and then we print it. Really simple one here. If we run that, I have a Docker Compose that also spins up a quick Redis service for us to show that. So if we run it and we get data, go rocks. If we wanted to change that in this example, just like how we did with the database, we would just change what our cache type is. So I could do not Redis, and it should then default to use the in-memory. So if I take that down and I run main.go, we get the same result, right? We're using the same interface, so it works exactly the same way. Something to note here is we create this repo, which is that cache.cache type, and then we put things on here, and this repo here is still the cache interface. We don't know what the underlying backend is. All we know is that it has these methods on it. It's just important to note there. Now, how is database SQL different than the cache, right? And if you've used it before, you might know that this DB that's returned from SQL.open is not an interface. It's actually a struct, and it has methods on it. So we're not getting an interface that is or a struct that's implementing everything in the DB. We're getting an actual struct that has implementations on it. So I kind of want to dive deep into that, and to show that, I really like to look into the Go standard library source to demonstrate it. So if we look at, we just peek the definition of the SQL.open, we see it returns a SQL.db. If I go to the definition of this, we can see that, and I go to the definition of DB, and we see it's a struct. It has a number of properties on it, talking about connections and closed things and a mutex, things like that, but it's still just a struct. And if we go back to in here, we can look at one of the common methods you might call on your DB to see if it's alive is to ping it. So the DB has a method on it to ping, and this one takes into context, so it's ping context, and it does a bunch of stuff and eventually returns a result of actually pinging the DB. And so what's really unique here is if we go to this DB, we look back at this struct, we have this driver connector, and that's how it actually talks to the database. So this connector connects to the database and then does everything else on top of it. So these drivers implement this driver connector and then the further interfaces they need to. We'll look at that a little more, but I kind of want to bring up this diagram that shows that. So we have the DB, that's the struct that I was just showing, and then we have the driver, and then we have like the PQ, the Postgres driver, or the SQLite driver. These drivers implement this driver interface, and then the DB uses that interface in order to make the calls. This is called the portable type and driver pattern. There's not really an official name for it. The Go Cloud Development Kit has kind of named it this. I like to shorten it as the driver pattern because it's a really long name. But you can see that the DB is the portable type, and then we have different drivers that can work on that portable type, which is really cool. So why couldn't we use normal dependency injection in the database SQL package? Well, there's a few things I want to point out here. Adding new capabilities requires all implementations to update. So if you were to add a new method on an interface, now all implementations, all the structs that actually implement that have to go and implement that new method so that it works everywhere. So it's a breaking change. Another thing is encapsulating functionality that is common to all database backends and all implementations is difficult. This is the biggest benefit I kind of see from this pattern is that database SQL does things like connection pooling or checking for a bad connection and beginning transactions and things like that, that the drivers don't have to implement that kind of stuff. Every driver, the Postgres driver, SQLite, it doesn't have to retry the connection several times. It knows that the database SQL will do that for them. On top of that, Go recommends interfaces to be small. If we wanted to create an interface for database, that would be huge. There's so many methods. So that's a big one. So that's kind of where this dependency injection gets elevated. We're able to encapsulate that functionality to all of them. And I was kind of showing that before, but I want to show it again. If we look back into that ping, and of course it goes into ping context and creates one, we see here, we're checking if it's a bad connection. And in fact, we try several times to connect to the database that to see if we can connect. And then once we've verified that we have a connection, then we actually ping it and we get the driver, and then we do the actual ping on there. So driver implementers, they don't have to go and build in the retry logic. They don't have to do any of those type conversions or anything like that. Database SQL does it for them because it's similar for all database backends, which is really cool. So these benefits are kind of anti of what the why we couldn't do it. The portable type contains common functionality for each driver. That's awesome, big benefit. Benefits or methods can be added to the type without breaking compatibility. So opposite to adding methods to an interface, which is a break and change, they can add methods onto the type, and as long as the drivers are there that already support it, it's no longer a break and change. They can do that without making all the drivers implement it. I think a really good example of this is if we changed the cache example to follow the driver pattern, then we could have added like a flush all or something like that would go and clear things. Even if the backend didn't support that clearing, we could have done that tracking ourselves, added in there, and then once drivers finally updated, use their fast version, which is really cool. Also, it removes the need for typecasting and conversions. That can be a huge pain when you're working with anything so we can do that within the portable type rather than inside the drivers, and then the users don't have to do it. So some big benefits there. Now, when we think about this pattern, what are some other applications for it? Big thing that comes to my mind are cloud services. So like blob buckets, AWS blob bucket or Azure blob storage. Google Cloud has its own equivalent, and all the other clouds do. You could use a driver pattern for that. They're all pretty similar, just doing storage. An event and message bus. So this is one that we're going to dive deeper into, but this is one we did at Vasion recently that was really cool. Last year, when I joined the team, we were told that we were using a homegrown event bus that was working for our current needs, but we knew that we were going to outgrow it as we scale and grow, and we needed to switch to something that was a little more ready, a little more proven in the industry. And so we didn't know which one we were going to go to yet, so we built a driver that worked with our homegrown event bus, and then we were just ready for once the decision was made, backing we were going to use. And we actually ended up picking RabbitMQ. And so we built a driver for RabbitMQ, and we were able to swap out the driver across all of our services in one big go with an environment variable. The driver was built and everything worked the same. It was really cool to see that switch and make that big migration all at once. Another example is Cloud Secrets or also caching solutions, like I was kind of talking about earlier. Caching will work really well for that. So I've talked a lot about this driver, and I've shown it, but I haven't really talked about what it really looks like. And what it really is it's an interface. And so it's funny because we talked about why we couldn't just do the normal interface pattern, but really it is an interface, but elevated. It has some wrapping around it that makes it really powerful, which is awesome. So I wanted to talk more about that event bus that I was talking about, using the same pattern or same diagram as I had before. The bus ends up as the portable type, and then we have drivers that work that. I really like an event bus as doing the driver pattern because you have a bus driver, and I think that's really funny. So as I said, we're using a Rabbit driver in our production system right now, and you could also build an in-memory driver. You could do a homegrown one. You could do Kafka. You could do any one of these. You just have to build the driver for it. And so part of today, I wanted to write a driver in front of us together, and we can see how straightforward it is to implement a driver. Now, if we go back to the code and we look at in our, let's see here. If we look at our 3 in our event, we have our bus, our driver, and our Rabbit driver, and then we have a main.go. So quick overview of this main.go. We're back looking at movies. I've preloaded this with a giant JSON that has a bunch of movies. And then all it does is we can print movies. We have a driver, very similar to the database. We do a bus.open. We subscribe to movies. We unmarshal them. And then we can push onto the event bus every movie. So forever, we'll just pick a random movie out of that JSON that I built, and we'll push onto it. Then at the same time, while we're subscribing, we build a consumer, we register it. And so for every movie release that comes out, we're going to just print it out. So ideally, with this running, we should see new movie released and then a movie coming out. So let's go ahead and run this right now. It's using Rabbit. So I'll spin up my Rabbit real quick. Rabbit takes forever to spin up. but hopefully it should come up pretty quick here. And then we can do run it, and we can see the result coming out here. So there we go, new movie released, and we're subscribing and printing it out, right? This will go forever. So I'll go ahead and stop it. And what I wanted to do today is, let's say for an example, we wanted to implement a in-memory driver. We wanted to use it for testing or some other use case, then let's do it. If we look at the driver, we see that the driver, just like the database SQL one, is a bunch of interfaces. We have this driver interface that opens a connector, which returns the connector. The connector, also an interface, that returns a connection. It's kind of deep, but finally we have a connection that does our two methods. We have a push and we have a subscribe. So if we look at our bus, we see we have our bus struct. This is the equivalent to the DB struct that we saw for database SQL. It has the connector. It holds some other things like what topics we're going to connect to, and a cancel function to cancel our subscription. So if we're going to build one for in-memory, we need a few files in here. The first one we'll need is a driver.go. So I put it in the wrong place, but there we go. This, of course, is in the memory package. Let's see if I can spell correctly. We need to create our bus driver struct here. So this is what actually will be used. And then we need to implement the methods off of our driver. So this one is our driver. So the method we need to implement is open connector. So for our in-memory, this isn't going to do much. Let's see here. It's going to be the bus driver. And then I'll just paste that I copied over. I'll bring the driver and I'll make sure I have the right import because there's a lot of them. Connector. And now ideally when you're opening a connector for an outside source like this, you'd want to create your connection. So this is going to create our connector. We haven't created that struct yet, but we will. Maybe we want to test our connection to make sure it works. So if it doesn't work, then we can return that error, right? And then we'll return our connection. Now, this last part is really important here. We need to initialize our driver. So this is how passing in the string, it knows that we have this. So we will register our driver and we'll call it memory, and we'll supply our bus driver here. So this is a really cool pattern here. You can look into after the talk, or I'm happy to talk about it. It's really cool. This is how we just pass in the string, and it knows which driver to use as long as we've imported it. So now that we've created our driver, let's create our connector. And this is in my way. Okay. So we have our connector now. This is the same package, memory. And then in here, we have our connector type. And let's take a look at what methods we need to implement on here. It's just connect. So that's not too bad. So we can implement that. So we'll go, we have the connector and connect. And this is going to return a connection. And let's make sure I implement the right driver. It's a long import string. And here, ideally, you'd actually hold some information like what your password is or anything like that. For our in-memory, we don't hold anything. It's just our connection, right? So that one's really simple. Lastly, we need to implement our connection. So if we go into here, it's the same package, memory. And I think for our example today, since it's in memory, we can use a global store to store our messages on the bus. So this can be, we'll use a sync.map. That way it's concurrent free, but really all it is it's a map and it has the topic.name, and then it will be a channel that is a driver.message, right? So we'll keep a map that has all the topics, and then we'll have a channel, and then in memory, we'll just put things on the channel. You get it off the channel for that topic, easy peasy. So then we'll create our type. So we have construct. And then lastly, just like we did with the others, we need to go and find the methods we need to implement. So if we look at push, we can go and we can implement push here. So we have our con, and we'll implement push. We have our driver.topic, and once I import this once, I should be good. and we have a driver.message. So to push onto our bus, like I said, we're just going to use a map. So we need to go and get our value off the map. So we'll go get it. We'll do the store and we'll load. If this topic hasn't been created yet, then we'll create it for us. So we'll get it up by the key, which is the name. And if it hasn't been there, we'll create it. So whoever gets it first creates it. Because we're using a concurrent map, we have to do a typecast on it. So we'll typecast it to our channel of driver.message, and that will be, we could call that CH. And so if it's not a channel.message, then we have a big problem. That's a big error. Hopefully it shouldn't happen. We control what's in the map, but that's a big error. Ideally, you'd put a better message there, but for the example today, it's okay. And then we'll just put our message on the channel, and we've successfully pushed. So that works for the push. So the next one we need to implement is the subscribe. I'll just copy that real quick, and we'll go back to it. And then we'll implement subscribe. Now, this takes in a number of topics that we're going to subscribe to. So we'll range over those topics. So topics.range. And I'll just rename this so it's nice. And then for every topic, we need to do the same thing as we did up here. We need to get it off the bus. So that's 5 down. So I'll just bring that down here. And then we'll create a Go routine for each of these. That way we can subscribe in their own Go routine. We'll take in the driver.topic and we'll take the message. So let's see here. This is a driver.message. That's right. And of course, we'll call this with our topic and our channel. So inside here, all we have to do is call, or we'll do error is equal to the topic.consume function. So we'll call the consumer with the message. We need to get the message first. So we'll just loop over all the messages on the channel. And then for each of those, we'll call the consumer. If we get an error there, we could log that say error consuming message on topic queue, and we could do that. So we'll pass in the topic name and the error, so we can have a print of the error. Finally, we need to listen until we're done subscribing. So we'll listen to the context.done. So we'll take that in, and then if we have an error, we'll do context.error. So easy peasy there. We've implemented those two methods. So now we've implemented everything in the driver for this in-memory database. So if we go back to our main.go, we should be able to just swap out our driver name here. So we called ours memory, right? So we'll do memory. And then the other thing we have to remember to do is to swap out our blank import. Now I could leave this one, it's not gonna hurt anything, but I don't wanna import too much. So now, let's see, Rabbit is still up, so I'll take that down. Just so we know that it's not gonna use Rabbit in the background. Rabbit is really slow. Okay, so now we can run main.go, and I have an error because I'm live coding. So let's see here. Memory. Oh, yeah. Yeah, you're right. Thank you. Easy peasy. So now we run it. We get the same results. Granted, it's random, so it's not the total same, but it's the same bus that's coming through, same messages. All these movies are getting released, which is awesome. So we were able to do that today in less than 10 minutes or so, which is really cool. So kind of a final recap on this pattern. Database SQL is complex. It's evolved over years of working and of them changing it and getting better. But it's really taken advantage of this portable type and driver pattern. If you look in there, it's pretty intense, but it's really cool to learn from when you look into that source code. Second, cloud services are really well suited for applications of the driver pattern. I'm sure there's others you can think of right now, but cloud services are awesome. And then creating a driver implementation is straightforward. We were able to do it within less than 10 minutes about today, just as I've been talking here. So it was really cool to be able to put that together with everyone. So Thank you so much. I hope you learned something about drivers. Thank you.